How many people have been my event before? Quick hand show. Good. And how many people have done Kaggle before? Good. What's the best rank? Anyone got rank 1? Oh, I know Owen is not here. Cool. So I started this meetup in May 2013, so it almost turned 3 years old. And the reason I started meetup is I used to do a lot of volunteer work, bring food for homeless. And one day I decided to teach people and give them more skill they can use. So I invite a lot of my friends and got a lot of sponsorship to run workshop to teach people data science skill. And after 6 months, I launched my own school called NYC Data Science Academy. And I always encourage our instructor, our students to teach more, share more. I think Kaggle is a great platform. I already spent several months. I even lost count how many months I tried to invite Anthony here. So it's really happening tonight. So I have a good friend, Alvin. We host his event too. He used to be #1 on Kaggle.com, Alvin Zhang.
Oh, yeah.
And his event was like crazy. 250 people came. We also asked one of our employees, he was ranked top 1%, to share how he did Kaggle. We also run several events to let people group to do Kaggle competition in our campus. So we're big supporter of you. Okay, Anthony and his colleague Will is here. Can you say hi to everyone? Greeting from London, right? You guys are based in London. San Francisco.
He's in New Jersey.
Oh, less special than London, but it's fine. Cool. So I want to thank tonight's sponsor, Work Market, especially the head of data.
Hi everyone, my name is Michael Gruen. I run the data team here at Work Market. So you're probably thinking what Work Market is, and even if you weren't asking a question, I'm going to tell you anyway. So Work Market is enterprise software that helps large businesses manage their on-demand labor. So in the case of Yahoo, which is one of our clients, they use our software to manage their entire network of bloggers across the entire United States. Just by setting an assignment out inside our platform, a freelancer picks it up, they deliver the work, we pay them, we rate them, everything is gravy. We're growing really rapidly. When I joined 2 years ago, we were 42 people. We're now about 105 or 106. I have our HR director, I think she just left, oh well. Well, we have a lot of people, and we're going to grow, probably double in size in the next 12 to 18 months. So really exciting time to be here. If you have any questions about Work Market, you can find me afterwards. There's some sheets over there. And enjoy yourselves. Thanks for coming.
Cool. So if you can send me the job opening link, I'm happy to distribute to the audience. Sure. Thank you. And tonight's superstar, Anthony, are you ready to speak to New York
Thank you very
community? Much. Okay, guys, let's get started. Please, let's welcome.
I had it a minute ago.
Okay. Do you want to check your bag?
Yeah, I think so. Sorry, just bear with me for 1 minute.
So how many of you already practice like data scientists? And data science wannabe? Data engineer wannabe? Good. So 90% of people want to be data scientists. And Kaggle is your fast track to be noticed. Here you are.
Thank you very much. All right. So thanks everyone for coming. So I think the question's been asked, but I didn't see the answer. How many people have made a submission to a Kaggle competition? All right, a decent number. So hopefully by the end of tonight, I'll have motivated everybody else. So what I'm going to do, I'm going to cover a couple of things. I'm going to give a very quick introduction to Kaggle just for those who aren't familiar. And then I'm going to talk about some of the lessons that we've learned. And I'm happy to make this interactive, so feel free to ask any questions. By the way, am I coming through clearly in the back? Am I coming through the mic? Yeah, very good. Okay. So when you come to Kaggle, you see a listing of competitions that looks a lot like this. So you'll notice the problems really range. Everything from taking MRIs and diagnosing heart failure, predicting at-risk populations for cervical cancer, for Genentech, trying to solve an 8th grade science quiz for the Allen Institute, Paul Allen's Artificial Intelligence Institute, predicting the stock market for Wyndham Capital, improving search relevance for Home Depot, helping Prudential streamline their life insurance products. So really a huge range of problems. I think that's one of the very exciting things about machine learning. It's what Andrew McAfee and Eric Brynjolfsson in their book, The Second Machine Age, call a general purpose technology. It really applies to any industry. Now, Kaggle's competitions always follow a very simple format. It's always supervised machine learning. So we have two data sets. We have a training data set and we have a test data set. So let's say you're a bank and you're trying to predict who's going to default on a loan. On the first half, we'll give you the features, so in this case, age and income. And then we'll tell you who defaulted. And on the other half, again, we know who defaulted. It's all past data. But we withhold who defaulted. We'll give you the age and the income. And you'll upload your submissions. And we'll score your submissions. And that allows us to show you on a live leaderboard how you're performing relative to each other. And in this case, you can see the leaderboard gives you the score. The lower the better. So it's a measure of error. And you can see that people have put in lots of entries. So you can put up to 5 entries typically per day. And every day, people are trying to outperform each other. Now, it turns out that doing data science in a competitive way has some interesting effects, one of which is it's a very, very powerful way to get everything out of the data. And I'll show you what I mean by this. So one of our very early competitions, probably the competition that really helped get us established and on the map, was a competition for NASA's Jet Propulsion Lab. And what they wanted to do was they wanted to take images of galaxies and measure very precisely the ellipticity of those galaxies. So the utility of this is, if you know the ellipticity of a galaxy, then you can, if the galaxy is stretched or if it's deformed in some way, it will tell you about the dark matter distribution of the universe. This is quite a difficult problem because you have atmospheric distortions, you have telescope imperfections, and so the idea was to sort of cut through that and figure out, measure as precisely as you possibly could what the ellipticity of the galaxies were. Now, first entry on this competition was made by, I'd never heard of a glaciologist, but by a glaciologist. His name is Martin O'Leary. Martin, he was British, he was a PhD student at Cambridge University, and what he would do in his research is he built algorithms that would take satellite images and detect algorithmically where the edges of glaciers were. Now it turns out that that algorithm was a very good fit for the NASA problem, also a shape detection algorithm. And so that got him into first place, and actually this is not always the case in Kaggle competitions, but very, very quickly, he had actually outperformed the best that NASA's Jet Propulsion Lab had been able to do. And this was exciting for Martin and exciting for NASA's Jet Propulsion Lab. There's, this blog post went up on the White House Office of Science and Technology Policy blog. Jason Rhodes was the investigator at NASA. And so he posted an article with a bit of background on this problem. And one of the things he said was that, for many years we've had physicists trying to solve this problem, and in less than a week this glaciologist has done a really good job. If you look carefully inside the post, they reference some of the background behind dark matter. They talk about, they explain Newton's law of gravity and Einstein's theory of relativity. And so Martin has both a Twitter account and a sense of humor. So he got on Twitter and he posted a link to this blog post, and he said, not that I'm bragging on nothing, but the White House has just compared me to Einstein and Newton. So he was quite pleased. But he didn't stay pleased for very long, because then somebody passes him. So Martin was in first, sent his friends, his family, that blog post, a link to the leaderboard, and then somebody's passed him. And you can guess what happens next. Martin gets ahead of them, then they get ahead of him, and he gets ahead of them, and people keep passing each other until you get to this point where there's not any more you can get out of the data set. So there's a limit to how much signal there is in a data set, and if you're working in isolation, you don't know where to stop. But when you're working in the context of a competition, people push each other to go further. And it's interesting because it's not like all people know about each other's algorithms are what's shared publicly on the forums, which is typically not somebody's secret sauce, but more just general helpful hints. And all you really see is the score that people get. So there's something about knowing what score somebody gets catalyzes performance that's better than somebody would get otherwise. I just want to pause there, and I said I was happy to make this interactive. Are there any questions? it's always a brave soul to ask the first question.
So the split between the training and validation data set, that is clearly you're looking at supervised learning methods. But for something like mapping dark matter, that seems like it must be more like an unsupervised problem. So how do you solve that?
So I'm going to repeat the question because I have a microphone and not everybody has a microphone, so that everyone at the back can hear. So it seems like the objective scoring means that we must be doing supervised machine learning, but it's hard to see how the NASA problem was a supervised machine learning problem. The answer is actually a little bit disappointing. It was a supervised machine learning problem, but what they did was they had quite a complex simulator that simulated these galaxies that had a certain dark matter distribution, and so the algorithms were trained on simulated galaxies and then applied to real-world galaxies. Yeah, there's a question there.
Do this for fun or for money?
So the question was, do people do this for fun or for money? It's a very silly way to make money because it's very hard to win a competition. And if you're smart enough to win a competition, then there are much better ways to make money. So the main reason people do it, the primary reason is to learn. So you get exposed to new techniques, you get exposed to new problems. That is by far the main motivation. I should say that Kaggle has become a pretty widely recognized credential at this point. So Owen Zhang, who we spoke about earlier, was at Travelers and then got poached by AIG and then got poached by a startup off the back of his competition performances. More recently, if you've heard of DeepMind, the company that Google bought that beat Lee Sedol in Go, I think they've hired 4 former competition winners. OpenAI, the Elon Musk funded research organization. The co-founder is the top Kaggle performer, a lot of top Kaggle performers. So if you don't have a PhD from NYU or the University of Toronto and you want to catch the eye of some of these choice employers, they're all paying attention to Kaggle competitions. And then finally, it turns out to be a good way to get your research recognized. So a good story here is when Kaggle started, the Random Forest paper had been written in 2001. Just a show of hands who's heard of Random Forest before. Very popular machine learning algorithm, yeah, so most people. So the Random Forest paper was written in 2001 by researchers at UC Berkeley. When Kaggle started in 2010, there wasn't really a density of competition participants. You had people using logistic regression and support vector machines, and some people were using Random Forest. It didn't take very long for it to become clear that Random Forest was the dominant strategy for most competitions. Sorry, I should say the dominant classifier to use. Then fast forward to, say, 2004, there was an algorithm called XGBoost. Was published by an academic at the University of Washington. Show of hands who's heard of XGBoost. That's a few less. This algorithm was then used not long after to win a large number of Kaggle competitions, and now the vast majority of Kaggle competitions are won by XGBoost. So Kaggle has become a way, if you've done good research, for that research to spread. The other one is that deep learning or deep neural networks, or whatever name you want to call it, the first time they won a Kaggle competition was in 2012. It was a competition for Merck to take chemical compounds and predict which chemical compounds were going to make the good drugs. The winning team was led by Jeff Hinton at George Dahl and 4 other of his graduate students from the University of Toronto. The second competition that deep learning won was by Vlad Min, who now works at DeepMind, was one of Hinton's grad students. And now if you look, anything that has, any competition we run that has images is won by somebody using deep neural networks. So it's when somebody uses a certain technique to win a competition, it's a very good way to grab attention. So those are the 3 motivations behind why people participate. Take one more question, then I'll go on.
How quickly do you get the point of diminishing return in general?
I'm not going to answer that now, I'm going to answer it later. So I'll show you a distribution of all of our competitions on a chart, you can see. So that's unusually fast, it's not normally that fast. And actually, you really, ideally, want a competition to end once you've hit that point, because most of the work that happens after that is, the company doesn't care, right? The reason companies host competitions is because, just say our first Fortune 500 customers Allstate and have a wonderful relationship. Actually, insurance is a good industry with us more generally. And they were curious, what sort of techniques do people use outside of Allstate, and how do our models benchmark against what's happening at the cutting edge? Are we close, or are we some way away? And if we are some way away, what are the kinds of techniques that get us to that limit? Other reasons companies use us is, I want to do something that's really pushing the cutting edge. So it could be, I'll give you another insurance example. So one thing that's in vogue in the insurance industry at the moment is, okay, so you've had a car accident, and they would have sent out an insurance assessor. Rather than sending out an insurance assessor, they'll get you to take a photo with your smartphone, and they'll use a deep neural network to try and figure out how much damage you've done. How accurate can an algorithm like that be? It's very difficult to know. If you run a competition, you find out very quickly, what is the best possible algorithm I could get on that problem, and then you can make the calculation as to, is that accurate enough to be useful? And just while I'm on the topic, the third reason companies use us is recruiting. So everybody from Facebook to Walmart to Airbnb host competitions where explicit, not like the DeepMind case where they're just looking at the leaderboard, but explicitly for the purpose of recruiting. I've mentioned this, we've worked in a large number of industries, large number of large and smaller companies. Actually, I've still got Owen on the slide. Owen is no longer number one. I think, is it Gilberto? Yeah, I think it's Gilberto from Brazil is number one, and Marius from London is number two. But these are our rankings. So we have a community of a bit over 500,000 data scientists now, 525 or so. And just like golfers are ranked, anyone who competes in Kaggle competitions are ranked. And the rankings really are a combination of how active somebody is on Kaggle as well as how their performances. So if you have a look, Owen's competed in, at least at this point, competed in 39 competitions. I get better 47. So you need to play a lot to be among the top ranked. So just to give you a sense for the level of activity on Kaggle. Oops. So we're now at the point where we're consistently getting over 100,000 machine learning models submitted in a month. Typically about 5 hours per machine learning model. So this is an enormous number of hours that people are spending on these competitions. I'm not going to go through the use cases. I want to get to the lessons because I think this is quite interesting. But before I do, I'm happy to take a couple of questions if there are any that I cut off before. Yep.
So how are the scores evaluated for submission?
Can you say that again? I didn't hear.
So how are the scores evaluated for each submitted any submission?
So the question is, how are the submissions evaluated? So what we do is everybody submits. You can submit up to 5 submissions per day. You'll see how you're performing on a public leaderboard. Then at the end of the competition, we'll throw away that test set and we'll retest you on a second test data set. And only those who perform well on that second test data set where you've had no feedback, that's how you get ranked. And so that's obviously to prevent against overfitting. The other thing we do to prevent against overfitting is of the, say you made 100 submissions, only 5 of them, you can only pick 5 that count, that get scored on that second test data set. Any others? All right. So I've already maybe given this lesson away, but there are 2 primary approaches that do well in competitions. The first approach is called the hand-rolled features approach. And so what this involves is, first of all, so you get a new data set. This will typically work on structured data, so data where you can have, I guess the simplest definition, or best definition I have for structured data is data that fits in mostly numbers or categories, and it fits in an Excel spreadsheet. And so you get this data set, and what you want to do is you want to explore it every which way you can. You want to draw scatter plots, you want to draw histograms, you want to draw correlation maps, every sort of explore. You look at the data as many different ways as you possibly can. And what you're trying to do is you're trying to get an intuition for some of the relationships that might exist in the data. So this intuition helps you create features. Now what features are, not to use jargon, it's creating synthetic variables. So the example I like to give, because I think it's a very simple one and a nice way to illustrate this idea, is a competition we ran with a company called DriveTime. What they wanted to do was they wanted to predict which cars sold at a second-hand auction would be good buys and which would be lemons. And so they had all the kind of characteristics of a car you might expect. The make of the car, the model of the car, the number of miles the car had driven. And the reason they cared about this is when they sell a used car, they have to offer a warranty. So they don't want to buy a car that they're going to have to fix within the year of its purchase. So it turned out that one of the top performers found that car color made a difference. And what they did was they grouped car color into standard color cars and unusual color cars. And it turned out that unusual color cars were more likely to be reliable because if you were the first buyer of an orange car, you were an enthusiast, you looked after it better, and so by the time it was sold at the second-hand auction, it was in better condition. And so how did somebody find that? Well, they found it by coming up with loads and loads and loads of hypotheses, most of which didn't work. You know, dark color cars versus light color cars, no relationship. But the idea is to come up with lots and lots of ideas and then be able to test which ones work and which ones don't work. And so you explore the data in order to give you a sense for what sort of features you might create, and then you create your features and you test whether or not there's a relationship. And then you put those features into a classifier, and I already mentioned this, but the classifier that's working best on structured data problems at the moment is XGBoost. So it used to be random forest, now it's XGBoost. For those who aren't familiar with XGBoost, it's a nice implementation of gradient boosting machines. So if there's one algorithm you learn, this is the one to learn. And it's also one thing that these non-parametric ensemble decision tree algorithms are actually really quite easy to apply. They're not difficult to train at all. So the vast majority of the effort needs to go into the feature engineering, and then tuning the hyperparameters on the classifier is actually much less of the time. So does someone want to take a guess as to what the second approach is that wins competition? Yes. So deep neural networks. So this works on all image competitions. It blows image competitions out of the water. We haven't done very many on audio recently. I don't think we've done any since then, or maybe the bird one, yeah, and the whale one. We haven't done many on audio, but it's said to do very well on speech recognition problems, for instance. And it's a bit of a mixed result when it comes to text. Sometimes it works well on text problems, and sometimes it doesn't. Now, this approach is very different because yes, there is a little bit of feature engineering, but actually the majority of one's time is spent basically constructing the neural network. So how many levels of depth? What is the activation function? So and most important of all with neural network-based solutions, how am I going to protect against overfitting? So it's sort of flipped. If 80% of your time for the structured data problems should be spent on feature construction and only a little bit on hyperparameter tuning, it's the opposite here. Now there are different flavors. I'm told there are 5 flavors of deep neural networks. The one that we see the most is convolutional neural networks. So these work on image recognition problems. So one of Will's competitions was to take images of the eye and diagnose an eye disease called diabetic retinopathy. And so just to give you a bit of background behind this illness, it's a side effect of diabetes if it's not managed well. If you have diabetic retinopathy, it makes you go blind, and it's eminently treatable. So if you can have an injection, or you can have laser surgery, laser therapy, I think it's called, and that will prevent you from developing diabetic retinopathy. However, a lot of low-income people don't get screened, and their diabetes perhaps isn't managed as well, and so it's a big problem. There's a shortage of ophthalmologists. It's expensive to get diagnosed. So the California Healthcare Foundation and UC Berkeley hosted a competition to take images of the eye and diagnose diabetic retinopathy. And so the eye on the top left is a perfectly healthy eye. It has a rating of 0. A slightly damaged eye has a rating of 1. More severely damaged diabetic retinopathy inflicted eye has a rating of 2. 3 is quite severe, and then 4, I believe you're blind. And so what the convolution, so this is a problem that convolutional neural networks did really well on. So the images on the left are the raw images taken from the fundus camera, and the images on the right are those that are processed by the convolutional neural networks, at least one of the top performing algorithms. The other flavor of neural networks that we've seen quite a lot of, I mentioned there are these 5, people talk about 5 flavors of deep neural networks. We've seen 2 that have done well in competitions. So the other one is recurrent neural networks. So recurrent neural networks work on, people sometimes describe them as working on data that has a time series element to it. I actually don't think that's quite the right description. I think it's data that has some kind of sequencing to it. So this is a competition. We've done a few EEG-related competitions. EEGs are electroencephalographs that they measure brain signals. So we've done a couple of these EEG competitions. We did one with the Mayo Clinic on predicting a seizure an hour before it would happen. We did another seeing whether you can figure out whether somebody's grasping or lifting based on EEG signals. Now, if somebody's the utility of that, it sounds, at first glance, doesn't sound very interesting, but the utility of that is if you can figure out if somebody's grasping or if they're lifting, you can imagine if you had a prosthetic, for instance, like the end results is you can think and move the prosthetic. Obviously, there's the difference between grasping and lifting is not a subtle difference. And so there's a lot of work even beyond that, but it's an exciting sort of beginning proof of concept for that use case. In both of those situations, recurrent neural networks won. Now, the interesting area is text. So text, we see a bit of a mix. Sometimes, so recurrent text also has a sequence to it, right? The ordering of the words matters. So sometimes we see text. Neural networks do well on text. So we had a competition, actually the one I mentioned earlier, that Vlad Min from Jeff Hinton's lab won, was taking images of, job descriptions and uploading them to an employment website and predicting what the salary for that job would be. So that was won by a neural network. And the utility of that for the job classified site was they wanted to give the employer guidance on what a benchmark salary for the role they were uploading was. We recently did a competition that I'll talk more about shortly for the Allen Institute for Artificial Intelligence to solve an 8th grade science test. And so this is drawing on corpuses like the Wikipedia corpus and other corpuses. And that was won by more classical information retrieval techniques with classifiers like XGBoost. So we still don't see neural networks totally dominating on text problems. We see them effective in some text problems. Any questions before I go on to lesson 2? All right. So I'm going to talk about some of the characteristics that we notice. So think about the sort of unique things Kaggle gets to see. We get to see a huge amount of data science algorithms. We get a good sense for what works. We also see a huge number of data scientists, and we get a sense for what are the characteristics of top-performing data scientists. The first one I've already hinted at is creativity. So with these structured data problems, you've got to come up with lots and lots and lots of features, right? How do you come up with lots of features? So you've just got to be, so it's really a case of being very creative, coming up with all the things that might plausibly impact whatever the target variable is. So that's one characteristic we see a lot. The second is tenacity. So this, I've shown this leaderboard slide. You're in first place, and then somebody passes you, and you've got to be so determined that you want to get ahead of them. And so tenacity ends up being a characteristic of top Kagglers. Third one is one that I feel very strongly about. I'm going to talk for a bit about this. So probably the most pernicious problem that we see on Kaggle is overfitting. Now, let me first talk about how this presents itself on Kaggle. So during the competition, we give you feedback on how you're performing on a public leaderboard, right? So you can see at any point in time how you're performing relative to others. And then we throw that data set away and we rescore you on a second test data set. So So if you're overfitting, what tends to happen is you're doing really, really well on the public leaderboard, and then we retest you on a second test data set, and then you don't do so well. So I'll tell you a story about the guy I'm talking about on this slide, the blog post. This is a blog post, and the person who wrote the blog post, his name's Gregory Park. So to tell you Gregory's story and what that motivated this blog post. So Gregory was winning a competition. He was in first place. He was very excited. And what happens is all the deadlines for our competitions are midnight UTC, right? And so he gets on his computer. It's 11:59 and 50 seconds, and he starts hitting refresh. He hits refresh, 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 refresh. He's very, very excited. He thinks he's about to, it's his first Kaggle competition. He thinks he's going to win. And finally, midnight rolls around, hits refresh, and he's not in first, and he's not in second, and he's not in third, and he keeps scrolling and scrolling and scrolling, and it turns out he's in 50th place. So that's why he called his blog post, How to Drop 50 Spots in 1 minute. And I've got to tell you this, Gregory has never overfit again. You learn the lesson. It's a very hard way to learn the lesson. Now, we see an unusual number of, not an unusual number, a huge number of first-time Kagglers have this problem, where they'll be tuning algorithms to the public leaderboard score, and then we switch over to the second test data set, and their score just plummets, right? Now this makes me wonder what happens outside of Kaggle. So research papers get written where the test data set is not quarantined. Algorithms in companies get written where the test data set is not quarantined. And so just given how much overfitting we see on Kaggle, I wonder how many, it makes it very hard to read a research paper and really take the results seriously when you see just how common it is to overfit. And the techniques for preventing against overfitting are not that hard. It seems like cross-validation. There's a researcher called, for those who don't want to waste any of their test data set, there's a researcher called Moritz Hart at Google who has written a nice paper on how you can not overfit while evaluating your algorithm within your training data. So there are well understood methods for preventing against overfitting. It's just, and by the way, I don't think people are intentionally overfitting. I think it is unwitting, and it is totally ubiquitous. And I think it's probably is the biggest problem, one of the biggest problems that we in machine learning and data science. And then finally, this is, I would say, of the 4 lessons, perhaps the least important, but not unimportant. So we see a lot of top performers will use version control. Now, you don't have to use version control, but if you use version control, you probably will spend about 1/5 of the time. Like, you can win a competition without version control, but you're probably working 5 times harder than people who are using version control. Reason being is you try lots of experiments, and some things work and some things don't work. And so keeping track of what's working and what's not working is, it's just like if you're not using some kind of decent version control system, it's very difficult to do. So we typically find that top Kaggle performers are not necessarily great coders, but are using good software engineering practices. So decent programmers who are using good software engineering practices. Any questions before I talk about lessons learned? Yeah.
Does Kaggle automatically do version control for you? When you upload your save field?
So historically, the question was, does Kaggle automatically do version control for you? Historically, we actually haven't, we've only taken submission files, not code. So we keep all your submission files, but we don't have the code that we have historically have not had the code that's generated. I'll show you, when I talk a bit about what's coming next for Kaggle, I will show you some of the things we're working on, including a code execution environment. And so we do version control, and we have diffs and a lot of the version control practices built into that software. So I will show you that.
Do you think being the winner of a competition versus being in the top few is just a matter of luck, and that if you kind of retrained on a different fold and then tested on a different fold, then maybe something else would have won?
So I would say now our competitions have become very, very popular. So we have competition. I think we have one at the moment that's got over 4,000 teams. And so it becomes the case that the difference between first and fifth or 10th is probably not statistically significant. It comes down to a luckily chosen random seed for some of the very popular competitions. I think that is the case for the very popular competitions, yes. No more questions? All right. Take a drink.
I mean, I have a question for Kaggle. So what is the mission of Kaggle? Where do we see the company in the next 5 years?
I'll answer that soon. Right. So I'm going to answer the first question that I owe a response on, which is, do all the competitions converge so quickly? And the answer is no. Sorry, before I want to set this up. So another thing we see is we see more, we see more machine learning models than pretty much anyone else. And so this is some interesting things you learn from studying the submission files that people submit to competitions. So first of all, some context. I remember I showed you that chart for the NASA competition. Well, this is a chart. This is quite a heavily engineered chart, but what we've done is we've made all of the evaluation, we've normalized the evaluation metrics, we've made it positive is better, and then we've broken them down into quintiles. So the easiest competitions, probably a little bit colorblind, I think it might be purple, whatever the top left color is. Those are the easiest competitions, they convert most quickly. So the NASA competition is probably in that decile. The hardest competitions maybe don't even ever convert. See the red line, which indicates that competition probably should have been run for longer. Now, what are the characteristics? How do we know that a competition is converged? So this is a correlation map from the NASA competitions. This is the one that converged very quickly. Now, the way you read this is the top left corner is the correlation between the first place submission and the second place submission. The bottom left corner is the correlation between the first place submission file and the 20th place submission file. And the bottom right corner is the correlation between the 19th and the 20th place submission files. Is that clear? Does anyone have questions on that? So it's subtle. So the test data set, people submit file, the answer key, and we're looking at the correlations between the answers. Right. So you can see the correlation is really high between first and 20th, right? You can't really distinguish a color. Maybe if maybe the TV doesn't have the resolution for it, maybe it's just indistinguishable to the human eye. But the correlation between first, second, third, fourth, they're all getting the same things right, and they're all getting the same things wrong. And the way to understand that is, there's only so much signal in a data set, right? And you're never going to be able to predict with 100% accuracy. So when we have converged on that limit, people are typically getting the same things right and the same things wrong. So now I'm going to show you a competition that was, so the NASA competition was probably in the fastest converging decile. I'm going to show you a competition that may not have converged. So this is the competition hosted by the Allen Institute for Artificial Intelligence. This is Paul Allen's, the Microsoft co-founder's AI Research Institute. So they wanted to figure out how well a machine could do on an 8th grade science test. So the question is the human eye. So I'll test the audience, see if the audience does, how the audience does relative to the machines. The human eye has receptors that can detect which parts of the electromagnetic spectrum. Is it A, X-rays, B, microwaves, C, visible light, or D, television wavelengths? So everybody here is correct, and every single algorithm in the top 20 got this question correct, right? However, if you look at the correlation map that I showed you before, the algorithm is getting very different things right and very different things wrong. And I do want to caveat this correlation map a little bit by saying that there is a little bit more nuance here than it probably seems at first glance. So the NASA competition, all the entries were really, really, really accurate, whereas actually in this case, the winning algorithm scored about 59% correct on the 8th grade science test. And so because it was a much harder problem, some of the errors would have been a bit random, so people are accidentally getting things different from each other or the same. So that error rate means that the natural correlation is going to be lower. But nonetheless, this is a very, very low. It's a Pearson correlation of 0.5. Or I think it's actually whatever Pearson, I forget what it, Pearson correlation becomes a chi-something correlation when you're looking at binary data. So this is looking at whether they get the same things right or the same things wrong. Question?
So it sounds like you guys use machine learning to predict what the optimal ending.
Yes, we could. The question was, well, it sounds like we could use machine learning to predict the optimal. We probably could. I think we've run, we don't actually have a huge data set. I think we've run about 250 competitions, which is a little bit small. But we have, if you include, we have a platform called Kaggle in Class, where professors host competitions with their students. So I think we've done about 800 or 900 of those. So maybe if we took all of the Kaggle in Class, we could probably do it. We actually have put the Kaggle data set up online. So you could probably do it. Send us the answers once, send us the algorithm once you've done it. Okay, so let's look at a question that, question?
These, where they have less correlation to say that the improvements in question were dependent on feature engineering.
Can you repeat the question?
So like the one from the Jack function that maybe like the features were already, features that came out in the initial data set were strong enough where people didn't have to focus a lot on feature engineering. There's more which algorithm performs that. But little tweaks here and there, things like this. Maybe this represents, much more of a reliance on the features themselves.
Yeah, I would just say this is a harder problem, or the people were calculating with less precision. That's partly the issue, but it's only partly the issue. Like, this didn't converge. Likely didn't converge, and if it did converge, the correlations would be quite a bit higher. So this is a question that half the algorithms got correct and half of them got incorrect. So motion with accelerated speed and motion with constant speed are represented by different equations. Which of the following equations best describe motion with accelerated speed? So it's interesting. So all the top techniques in this competition used information retrieval-based approaches or search-based approaches, right? So let's see words like acceleration, changes in velocity and time are words that appear in the definition of acceleration. So it's matching on those, but it's getting confused by the ordering, right? So it's quite interesting to study what the algorithms get correct, what they get incorrect, because it kind of tells you a lot about the limitations of those methods. Similarly, this is a question that all the top 20 algorithms got incorrect. So in many types of bacteria, offspring receive all their genes from a single parent. These types of bacteria, I'm going to try and embarrass everyone. So show of hands for A, show of hands for B. So A is produce very few offspring. B is pass on RNA rather than DNA. C is do not have different sexes. I've got a few for this. D is receive DNA from either the father or the mother. I think we got a lot of non-responses. Well, it turns out that people who did respond are better than the algorithm. So the correct answer is C. Most of the algorithms said A, a few said D. So again, you understand this when you realize that most of the techniques are information retrieval based. So you see the word parent in the question, and offspring and father and mother are words that you would associate with parent. Maybe the word single connotes few offspring. And so, as well as it being interesting to have access to these submissions, it's very interesting to see what the state of machine learning, what the state of machine learning can do and can't do on certain types of problems. Now, interestingly, one thing we can do is we can take the top 5 models, combine them all together, just poll them all and see which answers they would have selected. And you get a slightly higher score, right? You go from 59.3, which is the winning algorithm, to 61.6. And this is not a very smart way to ensemble. I'm just taking the top 5 and mixing them together. Now, if I tried to do this on the NASA problem, I would get no boost, right? Because everyone's getting the same things right and the same things wrong. What if I tried to be a little bit smarter? Only a little bit smarter. So if I look at the top 2 algorithms, what are the top 2 algorithms least correlated with? So less correlated is blue. So of the top 10, the top 2 algorithms are least correlated with 3, 4, 6, 7, and 9. So what if I ensemble just the least correlated model? Again, you get a slightly higher list. So this just shows that a smart approach to ensembling, where you're looking at where the algorithms don't agree, and you're focusing on where the algorithms don't agree, can actually result in a stronger model. And no doubt there are much smarter approaches to ensembling that would do it better. I only had 2 attempts at this because I know that overfitting it's very problematic. So I didn't want to come here. I probably could have come here and said, look, I can actually get to 99% if I take this very carefully weighted selection of answers. Okay, so this is a competition that just finished. It's one of the most exciting competitions we've done. It was taking MRI. Question?
For the last one, is there any thought of reversing it and engineering a test based on what the computers would be stable and answer properly, so that you actually understand what the science was?
So we've done competitions like that before, if I'm understanding the question correctly, where, say a company, for instance, has an algorithm already, and they'll host a competition to predict the residual. So basically all the things that their approaches have been able to get right. So we've done that sort of thing before. It wasn't contemplated for that particular competition.
So the really understanding
Right.
the parents and offspring of this.
Yeah.
It's a very low level understanding of that. So they're all testing techniques. Often
All right.
and so is there any thought to use from this time to help make
Yeah, actually, it's a really good question. So I should mention this. Some of the top performing algorithms, the guy who won actually asked their kid, who was about that age, to look at some of the questions and realized that there are, as you say, there are techniques that people use. I forget what they, so he actually had some of those techniques to speak with. Like, this is an example of a technique that I don't think one of you use. Like, we'll have 5 C's in a row, for instance. So if the past 3 answers you have high confidence in a C, then the next one is unlikely the same letter. So what he found is that the vast majority of the work is done by the search relevance, the information retrieval features. He got a little bit of a boost from the gaming the test type features. So you're probably right. You probably could use these algorithms to design better tests, such that you won't want those features are and take them out. But I think in practice he found that the information retrieval was far more important than the gaming test. It gave him, he broke it up in his, he did a winning write-up, and he broke up the amount of his performance that was due to gaming test versus. Alright, so this was a competition to take images of the heart and diagnose, MRIs of the heart and diagnose heart failure. This is a really tedious exercise for a cardiologist. So what I'll do is, you see this MRI is you see in the top right corner it says ED and ES, right? So the ED is when we pronounce the word that diastolic, that's when the heart is full, and systolic is when it's empty. So a cardiologist doing this will look, what's this MRI? They'll pause it when the heart is full. They'll draw a circle around the left ventricle. They'll measure the volume in the circle. Then they'll pause it when it's systolic, when it's most empty. They'll draw a circle around the heart when it's empty. What they're trying to measure is the relative volume, or call it ejection fraction, the relative volume of when the heart is empty and when it's full. And so they look for this image, but then they have to do it 30% trying to automate this process. And what they've tried to do by basically coding into software that the cardiologists do. So convolutional neural networks come along, and all of a sudden we don't have to say, okay, first locate the left ventricle, then program the computer deterministically. All we did was take, what people did was they took the images of the MRIs and the measure of ejection fraction and trained convolutional neural networks. A little bit of feature engineering as well. And we ended up with algorithms that, like with the ophthalmology example, match the average diagnosis of the cardiologist. So so a healthy ejection fraction is between 50% and 70%. Two cardiologists looking at the same MRI are within about 6 percentage points of each other. And the winning algorithm is within 6 percentage points of a cardiologist. So that's just an interesting result. And certainly one we're proud of. This is one by convolutional neural networks. I said earlier that there used to be all the top machine learning labs that were using convolutional neural networks. Actually, the winners of this competition were both, at the time, hedge fund traders. So one was at Two Sigma in New York, and the other was a health tech graduate who worked at a company in Los Angeles. Now, let's look at the correlation map for this competition, because this one's also interesting. So you see that first is highly correlated to second, highly correlated to third, highly correlated to fourth. The fifth is interesting, and eighth is interesting, and ninth is interesting. And also, if you have a look, fifth and ninth and seventh are highly correlated with each other. So it turned out we emailed the people who fifth, eighth, sorry, that was fifth, eighth, we emailed a couple of them to find out what they had done. And it turns out they had used, drawing a blank on what the name is now, they had used quite a different technique. So actually for this problem, there are two techniques that do relatively similarly. And possibly, well, in this case, on some we wouldn't make an improvement because we're limited by the quality of the ground truth. So we can't do better than the ground truth we have. But it's at least interesting that two different approaches somewhat independently got the flights in this case. Yeah, 12 doesn't look correlated with anything. I actually don't know. I don't know what's happening with 12. We never worked on it. Good question. I'll follow up. Seems that 12 is interesting. It looks like it's the same amount correlated with 6, 7, and 10 as it is with first, second, and third. Sorry? Yeah, it could be both. Yeah, very good. It could be an ensemble of both. It's actually a sensible conclusion. Very interesting. Good. I've got homework. Any other questions? Okay, so now I'm going to ask the other question I promised, answer the other question I promised to answer, which is, what is Kaggle aiming to do and where next for us? Now, I want to do a demo. Oh yeah, question.
The question is, is there any sponsor that afterwards request you to look into other than top 3, like interesting contemporary solutions?
So the question was, are there any competition hosts that want to look at that, the correlation maps and dig in a little bit more? So just to give a little bit of background to this, so we typically recommend that prize money is paid to the top 3 or the top 5, not just the winner, for a couple of reasons. To the question back earlier about, is it, the top performers are typically not statistically significantly different from each other, or in many cases they aren't. And so it's good to reward, like if you happen to pick the wrong random seed, you don't want that person to not get anything. Second reason is also from the company's perspective, it's good to have a selection of algorithms because sometimes The third place algorithm, which actually performs just as well, is more elegantly implemented and easier to implement. No one has ever asked us for the correlation maps before. We haven't really, the only reason we did it, so we passed the 2 million submission mark recently, and that was a trigger to spend a bit of time to reflecting on some of the lessons that we had learned. And so it's a relatively recent thing we've done. I think we shared it with the Allen Institute for artificial intelligence. So we did share it with them. It's companies like that have more of a research or an R&D agenda that are going to be most interested. A lot of our customers are most interested in sort of benchmarking where they are relative to the frontier, and then getting a sense for the techniques. They're not. It's only really the research-minded customers who are potentially more interested in looking a little deeper. Is there a question there?
Yeah, you may answer it as a follow-up. Considering that the benefit of publishing is to promote your algorithm, particularly with respect to KDD, both the journal and the how do you see it?
Sorry, what's the question?
With respect to like researchers wanting to promote their, like being forum to promote their research and algorithms, what's the relationship? Where do you see Kaggle's relationship with KDD Cup and KDD knowledge discovery?
Sure. Yeah. I think we have a reasonably good relationship more generally with academia. So I think every year for the last couple of years we've done a workshop at NIPS. So that's a conference we're typically involved with. As you can see, a lot of researchers participate on Kaggle for the purposes of it's sort of another way to get adoption faster than the journals. With KDD, we've historically run the KDD Cups. It really depends on who the sponsor is. So if the sponsor wants to put up their own website, they put up their own website, as in the company putting up the problem. But KDD and the KDD Cup know that we're always willing to help them sponsor, put up their competitions. It's just, yeah, but it's, so sometimes we're running them and at other times we're not. I'm sure there is more generally that we could be doing with academia. We're a small company, we're much smaller than you might expect, so we're 12 people. And so, which is surprising. It's actually probably the thing I'm most proud of about Kaggle. Like, we're very small and we get a lot done. But that also means we have to focus. So for us to be a 12-person company that does what we do, yeah, it means that we are not pursuing absolutely every opportunity that we could, and deeper engagement with academia or a more formal engagement with academia is absolutely, would be, I think, valuable to the world, but we just don't do it. By the way, this is probably an opportune time to say we're hiring not machine learning or data science, we're hiring software engineers. So if you code in C#, ASP, MVC, the Microsoft stack, we are hiring software engineers, and you'll be working on what I show you next, which is very cool. All right. I'm going to try and balance this. You know what? There's not a microphone stand, is there?
I can go for you.
You can be my microphone stand, or I can try and speak loud. All right. Cool. All right, so one of the things, for those of you who have been participating on Kaggle, I might, I'll hold it.
Oh, no, that's fine, it's fine.
Okay.
Just want to close.
All right. So I got it.
Okay.
Thank you. I won't be able to hold it together otherwise. I've never had a human microphone stand. Thank you. Okay, so for those of you who have been participating on Kaggle, you might have noticed that we have this new feature called scripts. And for those of you who haven't, it's a really powerful feature, and we have really big plans for it. So I'm going to show it to you now. So one-handed typing. Oh. Just noticed NVIDIA are promoting on our, they're buying AdWords on our name. Okay, so you come to Kaggle, you see all these. Oh, it's not on. Right. So only I could see that in video where I accidentally Googled Kaggle and came up with. All right. It came up with NVIDIA. Very good. All right. Okay, so you come to Kaggle and you see all these competitions. So this is an example of, and actually I'll pause here. So if you're new to data science, one class of competition that we have is we have these getting started competitions. So these are really simple problems. The easiest is this Titanic problem where you're trying to predict who survived the Titanic based on things like sex, gender, age, etc. Here's a hot tip. If you want to do, you can get 75% accurate on that competition if you just take if female then survived, if male didn't survive. So that is a legitimate algorithm to submit to a very simple decision tree. Anyway, so that's a very simple problem that you can start off in Excel and then upgrade to Python and R. Another of our simpler competitions is this digit recognizer. So this is a very famous, well-studied benchmark data set. And what you're trying to do is you're trying to take these digits and classify them. So, you know, this one's a 9, this is a 6, this is a 6, this is a 5. Now, I've already mentioned that we have these forums. And there's a lot of discussion that happens in the forums. You can see over 1,000 posts. Now, one of the, just for this particular data set, which is not even necessarily one of the more popular ones, and one of the things people post is code. So you can see here, this person has posted their Python neural network code. In order to get it running, you need to have the same version of Python, so 2.7 or 3.4. You need to have the same libraries, so pandas, scikit-learn, matplotlib, numpy, nodelearn, and lasagna. Now lasagna, I believe, recently changed their API, so you probably have to have the same version of lasagna that this person is running. You have to have the same data set. So, you know, this person has very generously shared code. It looks like it's code that performs quite well, but no one's replied. It's just a huge hassle to get their code running, and you don't even really know what's in it. So what we have is this new feature, a relatively new feature on the site. Oops. You can see here called scripts. So you go into new script. Apologies, I'm on my MiFi, so it's a little slow. So you get an R Python or a Julia environment. The data's already read in. All the machine learning related packages are installed. You can start coding immediately. You hit run script and it runs in a Docker container on our servers. Now, so you can use this. It doesn't. It's a totally free. Doesn't cost anything. We cover the compute on one condition, that everything you share, everything you use it for is shared publicly. Now we will have this, we'll have a private version of this, but for the moment everything is shared publicly. So you can see the scripts that people have shared. So the most highly voted on script is a deep neural network using Google's TensorFlow library. And you can see there's been 23 comments, there's a lot of discussion. So there's a lot of interest in deep neural networks, there's a lot of interest in TensorFlow. This is a notebook that takes you through how to use TensorFlow on this particular problem. So it's very popular. I'm actually going to demo on a different script, which I think is less popular but really cool. So this is a script that uses a random forest, and then it visualizes the digits and looks at their proximity to each other. So if I look at the output, you can see here, the 9s have been grouped together, the 4s have been grouped together, the 7s have been grouped together, the 7s are near the 9s. So this is a nice diagnostic for this algorithm, right? You can see how exactly how the digits are being classified. You can also see which ones it's not doing a good job of. So the ones in red, it's getting wrong. So it's consistently getting the 7s with the dashes through them wrong. And you can see this one has a bit of a tail over it. So it's not a big surprise that it's getting confused for a 9, right? So let's say I wanted to work on the 7s with the dashes through them. So I hit fork script, and I get his code running in an environment that will run it immediately. So there's none of this installing this library and that library, and I can edit it and hit run script. Now, if I compare, this to, so this has been forked 32 times. So you compare that to the forum post where no one responded, and this isn't even one of the more popular scripts, right? So there are two things happening here. One is there's none of the clunkiness in getting somebody else's code running. It makes it really easy to fork somebody else's code. And the second is I can see what the code produces straight away. So both of those sort of lower the, make it much more both inviting and easier to build off somebody else's work. So this, if you look at our competitions, most of the competitions now, you can have a look, most of them have scripts attached. So the State Farm competition to take photos taken within a car and figure out whether somebody's using their phone or doing something else distracting. There are scripts that will help you get started on this competition. And a lot of people write really helpful scripts. I'll show you one that I like from, let's go look. So this is a competition for Springleaf. It was a marketing response competition. You can see a lot of the kinds of scripts that people share do some of the heavy lifting that's not that much fun to do. So you can see in this case he's cleaning up city names. So you've got Brooklyn here was spelled with 2 L's, and he has written code that gets the names correct. You can see you've got the code. So a lot of times people are sharing, not necessarily sharing their secret sauce, but often sharing sort of very helpful things that you can use in your pipeline, as well as examples of things like TensorFlow and XGBoost and so on and so forth. Tianqi Chen, who's the creator of XGBoost, is very active in using scripts to demonstrate how XGBoost works. The other thing we've been doing is we have put up public data sets. So this is to try and broaden. So ultimately we want Kaggle to go from something that people use for their side projects or for competitions to a broader range of side projects, and eventually we want Kaggle to be the thing you use every day. And so this is, our first step was broadening from competitions to other things. And so actually only a couple of months ago we launched public data sets. So we have lots and lots of different kinds of public data sets. Hillary Clinton's emails are quite popular. So if we have a look, actually this is the same person who wrote the Springleaf cleaning up data. He has a script to look at sentiment about countries on her email. So hopefully you can see she's quite partial to the Marshall Islands. She's not that keen on Iraq. So you too could take this script and you could run it on your co-workers' emails, for instance. See what you might be leaking about, which co-workers you like and which ones you don't. But in all seriousness, now you have code. We probably have many, many sentiment analysis examples, right? So you have the code that runs this. And so soon you'll be able to bring your own data sets. Again, it'll all be public, but if you're working on a research paper, for instance, you want it to be reproducible and you want other people to be able to sort of work on the same data or fork some of your work. This is a very good place for it to live. Eventually, this will become something where data scientists and companies can pay and keep their code private. And so you can fork from the public examples or you can fork from your co-workers. But the idea is that this will be sort of an overall collaboration environment for data scientists. And there's a lot of work that is going into it. So things like, at the moment, the editing environment is either a notebook environment or it's our script editor. Eventually, you will be able to use your own IDE and push and pull onto Kaggle. Pipeline support. So it's not just data script output, but longer chains of analysis. So this is something that's under very active development, and it's going to be a big part of our future. And so the way to think about this is, Kaggle started out with competitions. That's been a good business for us. As we sort of look to grow and expand, we want to do other things and become a bigger and bigger part of the way data scientists work. So with that, I'm going to stop, and I don't know how we're doing for time. There's a question. Are you all right for time? Yeah, okay. So I can take a couple more questions.
Yeah, so my question was actually more about what is the mission of Kaggle, right? Because I think on the volunteering side of data science, we have data time, we have
Actually, I read a Financial Times article yesterday. It was a new company called Numerate AI. They also host competitions and people compete for money. Actually, some of the masters compete as well. So I'm just wondering, like from Kaggle, I mean, I personally identify a lot of them. But then, I mean, I don't feel like, I just want to know what is the business model and expect how you actually go to, really make a lot of, I don't know.
So there's a difference between our mission and our business model. Our mission is to help the world learn from data. So whether it be through competitions, whether it be through scripts, whether it be through public data sets, we want to give data scientists a central place with which to learn. And I think we have, to some extent, accomplished that mission. So, or we've done a lot to accomplish part of that mission. So if I look at some of our proudest achievements, it's helping really good, I say Kaggle is a really good BS test. So you can read an academic paper and the algorithm is always benchmarks on all these data sets and it's much better than all the others. Well, I think Kaggle is really great for sorting out which techniques are really powerful and which ones aren't, and which and it's helped spread that knowledge. So that's one way we help the world learn from data. I think that thanks to Kaggle, I think overfitting is one of the biggest, most poisonous parts of data science, and I think a lot of people have learned through competitions about overfitting and that it's an important issue. So to some extent we have partially achieved that mission. I think things like scripts make a huge difference. When we first launched scripts in competitions, we either got complaints or it was ignored. Now when we don't have scripts on a competition, we get complaints. So people have found it useful as a way to see other people's code, as a way to build a portfolio beyond just competitions. And so that's been the next level. As we continue to develop our scripts, we want to allow people not just to collaborate out in the open, but also within a company, so be able to collaborate with each other, fork off each other's work. So all of this is helping data scientists. The mission is to help the world learn from data and make everybody both more productive and stronger data scientists than they would be if Kaggle didn't exist.
What business model?
What's our business model?
Yeah.
So we have a few different revenue streams. So companies pay to host competitions. We have a jobs board. So those are the revenue models. At the moment, scripts will be another source of revenue. So we started off with one product, which was competitions. Now we have the jobs board, and the next one will be scripts. Question?
How do you see you fitting in the data hosting space with the federal and state local governments that are hosting open data sets as well? Where do you fit in?
Yeah. So I think it would be. We have the ability, and a lot of the data sets that we have up, those data sets are all licensed such that they can be reposted on Kaggle. What we ultimately would like to see happen, one of the things that we're developing over the next half year is we're going to allow organisations to have a profile. And so if a state government wants to post their data on Kaggle rather than on some site, they'll have the ability to do so. Or if somebody wants to post on their behalf. And the advantage of doing that is you can post on some city of Chicago.data.gov.whatever, or you post here where you've got 520,000 people actively participating, you've got a ready audience. So I think it's quite a compelling place for anybody with open data to post open data. At the moment, we don't have that ability, so we're the only ones who've been posting data sets. In the next 3 or so weeks, anybody will be able to post a data set. And so that's when, we would hope to see open data sets. I mean, whatever people are interested in working on, we think this is an interesting place to do that work.
So now, since you're also saving scripts, do you have any plans for when you'll host the first Kaggle competition on winning Kaggle competitions?
I don't know. I don't know about our competitions. So scripts, I think, will do. Scripts, I think, can do a lot of powerful things. We'll host competitions that are script-only competitions, and we would like to be able to, as you're using scripts, be able to look at some of the high-performing scripts that other people have contributed and and sort of suggest, like say I'm trying to do sentiment analysis. It'd be really nice eventually, not necessarily to give you a competition-winning algorithm, but to be able to say, okay, looks like you're doing sentiment analysis. Here are 5 example scripts that do sentiment analysis that have some interesting ideas that you might want to borrow from. So that's more something that I think we're going to do with scripts. Yeah, so it's
many of the winners are heavily ensemble the model. In real world, probably not very technical. So do you have like a plan to encourage more simple, elegant solutions?
Yeah, so the question was, many of the winners ensemble their models, and they end up with models that are quite complex. Do we have a solution to that? So a couple of things that we do on that front. So one is, first of all, we pay prize money to the top 3 or the top 5, because some solutions are more elegant than others. The other thing we do is, so what the winners submit, as well as their winning algorithm, is they submit code documentation and they do a screencast. And one of the sections in the documentation is simple models and methods. So is there a model that gets you, 98% of the performance of the winning model, but this uses a handful of features in a single classifier? Because in practice, that's what a company wants to put into production. So we have a couple of ways. The reason we've never hosted competitions that require a certain execution time or restrict in some other way is there are a few problems with that. One is just its lack of simplicity, right? So one thing that's really nice about Kaggle is it's purely objective, it's very clear, like there's just a single number you're shooting for. The more complexity you add, the less fun it is, the harder it is. The other reason we don't do it is actually it's eminently gameable. So what you could do is, let's say so one thing to remember is we have a very smart community, and anytime there is a way to game something, people will figure out how. So I'll tell you how this gets gamed. So let's say you put an execution time restriction out. What people would do is they'd train the very, 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 very best classifier they possibly could with no execution time limit. And then they would create something that executed very quickly, but overfit to the results of the very, very accurate classifier. That's the kind of way that somebody would gain an execution time requirement. So that's why we don't do it. And in practice, it's relatively, like the trade-off between execution time and accuracy is relatively flat. And so the methods that we have for getting people to simplify their models end up being more effective. Maybe I'll take one more question. Okay.
You mentioned about the information distribution component. What type of things are normally used?
Sorry, I didn't hear the question.
You mentioned about this information retrieval techniques before.
Yeah.
So what kind of techniques are normally used by folks like that?
It's like information retrieval techniques.
What kind of techniques are used?
What sort of information retrieval techniques? So it really depends on the problem. So probably the best thing to do, if you're interested in information retrieval techniques, but actually just more generally, I think this is a good tip. So we have a blog, and it's quite good. What we do is very often, assuming the company hosting the competition permits it, the winners will post varying levels of detail their solutions. And so it's almost like a living journal of what really works. So I suggest taking a look at that. So the kind of competition, so the Allen Institute competition is one example where information retrieval techniques won. So that's a good competition to take a look at. So that's probably I would go and look at the blog. I think you'll get much detail, much better on the kinds. Look at the competition you're interested in and the blog post that goes with it, and you'll get a good sense for what won. All right, thanks very much. I mentioned, as I mentioned, we are hiring. We're hiring C# developers. I'll put my email address up. So if any of you are or know any C# engineers, please do get in touch.
How many openings?
As many as we can hire. All right. I'll get there. All right.
All your scripts running on Windows machine or?
Yeah, we run on Azure. So we have, so being a C# Microsoft Stack company, all of our stuff runs on Azure, and that works out quite well. We have a good relationship with Microsoft, so we get quite a lot of free compute, which is good. That's how we can afford to make scripts free.
Maybe you should get some deals for more competitive.
Yeah.
We use that.
Well, yes, we would like to. So one thing we're trying to do is get competition hosts to start sponsoring compute time. So we have, particularly for some of the script-only competitions, it's something we want to do. So we know that people are paying for compute, and we're trying to get competition hosts.
You can get Amazon or Microsoft.
The free compute, yeah. So our number one priority is getting ourselves free compute, and then it's an issue we're aware of.
I mean, sometimes companies do sponsor, right? Like Kaggle competition, they give
Right.
their software for free.
Yeah. Thank you.